sound like AI? AI is a smart robot friend that you can learn and do things. It can learn and do things just like you. It can understand your words, recognize pictures, and even play games. It learns by practicing and gets better over time. Just like you learn from books and stories, AI learns from data. It's used in cool stuff like talking toys, self-driving cars, and helpful robots. Just remember, AI is like a clever buddy that wants to help and learn new tricks and make our world more fun and exciting. Who thinks that sounds like AI? Okay. How about this one? Artificial intelligence, AI, is the intelligence of machines or software as opposed to the intelligence of human beings or animals. AI applications include advanced web search engines, e.g. Google search, recommendation systems used by YouTube, Amazon, and Netflix, understanding human speech, such as Siri and Alexa, self-driving cars, e.g. Waymo, generative or creative tools, ChatGPT, and AI art, and competing at the highest level in strategic games such as chess and Go. Who thinks this one sounds like AI? You guys are cheating, you're voting on both of them. It's not both. Here's the big reveal. The first one was written by ChatGPT. Second one we took from Wikipedia. Did you get it right? Yes. You voted on both of them. You had to get it. Cheater. You already read the Wikipedia article? Alright, so what is generative AI anyway? So today we're talking about generative AI for text, so large language models. So here we're talking about, compiling a lot of text data, and we're giving it to the model, so the model can sort of learn from what it sees. It's creating this large probability matrix. And really what generative AI for text does is it predicts the next word in the sentence. It doesn't know what the sentence says. It doesn't learn what the sentence means. It's just looking for the next most likely word to come in the sentence. And a lot of us probably use large language models every day. I mean, have you ever been typing in your email and it starts to suggest the next couple words? Or in a text message? You're using a large language model right there. But I do have to say that large language models are not search engines, and they're not fact checkers. They do suffer from these things called hallucinations. So when they're predicting the next word in the sentence, it doesn't mean it's the right next word. It doesn't mean that it's a factual next word for what the sentence is trying to convey.
So yeah, there can be problems with generative AI. Has anyone heard of a deepfake? Yeah, deepfakes are scary. There was a pretty famous incident, I think it was last year, with the president of Ukraine being imitated by a deepfake. That was pretty, debunked relatively quickly, but as artificial intelligence and machine learning and technology just advances exponentially, these are going to be more and more real of problems. So one of the things that I was a tutor for a little bit. I've never officially taught before, but the problem is also, with ChatGPT that came out last year is, our students actually writing their own essays, and whether or not that matters is kind of up for grabs these days. It's kind of like, now we just need people who can put it into ChatGPT, and then who cares? We don't need to write essays because ChatGPT can do it. That aside, I would still argue that we still want to understand when it's actually being done, just to be ethical about it. So that's just one narrowed in example of what the problem is. But yeah, so that's what we're trying to solve. So we used a specific use case. One solution is just to use AI to, as I was saying before, to try and predict whether or not a given set of text is machine generated or human generated. So we used a data set that was produced by a few ways. There's two parts of the data set. One is, of course, human generated text, and then two is going to be machine generated text. So we used 10,000 records in this case. Relatively small data set, but still large if you think about someone sitting in front of a computer and typing into ChatGPT and then getting like some result out of that. So when I was collecting this data set a few months ago, this new OpenAI API that uses the ChatGPT, which does anyone know what under the hood ChatGPT is what the engine is kind of. GPT 3.5, and so I was using GPT 2 a few months ago, but I think they have an API right now, so that'll be part of the next steps. But in any case, for the machine-generated text, I used a GPT-2 output, so I just gave it a data set and then just iterated through to produce a bunch of data sets, and eventually I narrowed that down to 5,000. For the human-generated text, I used Medium articles and Wikipedia articles. Like the one right? This is just an example of what the data distribution looks like. Ideally, you want to see kind of like something that looks even, so that it's relatively fair. If you can do that, that's not always like a realistic assumption. But on this side is what did I do? So this is kind of what we want to focus on. Is it machine generated or is it human generated? And then with the human generated, we used Medium and Wikipedia, but with the machine generated, we used Rotten Tomato inputs to send through the GPT-2 and then get machine generated, as well as WM16, which is like a translation data set. There's multiple languages, so what I just did is I just extracted these little like English excerpts to get some data out of that. And then it's just put in a different way over here. So again, I had more than 5,000 records for each of these, but you know, to reduce the bias as much as we possibly can in the data set, what we can see on the left-hand side is these are word counts. So these guys were super short in terms of word count, but these were super long. So what I did was I extracted the articles that only had this many word counts so that it's a lot more even amongst the data set. And that ended up being, with some trial and error, dart throwing, between 50 and 450 word counts. Once we got into the experimentation phase, we used a few different vectorization techniques and threw them at some of these models: naive Bayes, support vector machine, random forest, logistic regression, convolutional neural networks. There's a typo on this slide that should be LSTM for long short-term memory, as well as XGBoost and Gridchurch. And then we used SHAP for explainability to try and make an attempt to say, okay, this is why the model is saying whether it's this or that. There's a few ways you can evaluate whether a model is successful or not. A super easy, quick and dirty way is just looking at various metrics, such as accuracy, precision, recall. The one that's highlighted right now is the best one. This is for a TF-IDF model. That's just a vectorization technique. Just really high level. There's bag of words, TF-IDF, and then if you remember, if you ever used Gmail, a few years ago in like 2018, 2019, it just magically started reading your mind with the autofill. So that was BERT. That was a transformer model. That's a very sophisticated vectorization technique. TF-IDF is just like a fancy word frequency. So these are pretty graphs, and I really wanted to include them. But the point is, we want to see variation in our data set. Otherwise, it's not really, our models aren't really doing anything useful for us. So bag of words is just like, this doesn't actually want to move. Bag of words is actually, this is on the top level, it's just like a fancy word count, or it is just a word count. So we're actually just seeing that kind of the machine is the blue and the human is the red, and they're kind of hanging out together. So when we go into the more sophisticated vectorization technique of TF-IDF, they're kind of like splattered around and hanging out with each other, so that's like a lot better. So that was what I wanted to point out with this. On the right-hand side is just colored by source. They're still kind of hanging out with each other, like both models, but that is one of the limitations of this a little bit. So explainability is important. With bag of words and TF-IDF, it's relatively easy to use the SHAP package to say these are the words that kind of helped the model make a prediction. When you get into something more sophisticated, like a BERT embedding, on the left-hand side, it's just like, here, these are the numbers that, you know, it's very difficult to have explainability with a transformer. There is research going into that right now, but as of now, that's kind of where it stands. So challenges, collecting the data, general architecture, the environment, we ran into memory issues, we ran into software dependency issues, and then of course our data set is relatively limited as it is, so we want to get more interesting data as well. And then can we even trust this model? That's definitely something that we always want to consider. But again, pretty much because the data set, we want to continue getting more data. And I'll hand it over back to Rachel. So what?
Yeah, so what? So online users should be able to expect that social discourse is between two humans, unless they're told otherwise. Humans can be manipulated by each other, of course, but using fake bot accounts to bolster numbers of followers or to promote narrow points of view is just detrimental to our society. It's detrimental to each other. It's bad stuff. The newest research suggests that training a new large language model on the outputs of another large language model results in this phenomenon called model collapse. So, new researchers, post ChatGPT when we don't know, as we proved here in this room, what's human written and what is generated by AI. New researchers will need to run all their new training data sets through models like this to make sure that they can remove everything that is generated by ChatGPT or other large language models. And that's it for us. Thank you.
Thank you.